Mr. Shepard, do you feel safe? You okay, Mr. Shepard?
All right. So I'll give you this. And you can either put it in your hand or just kind of toss it back into your mouth. You don't have to do it all at once. Whatever you're comfortable with. I usually do like half at a time. Okay, great. They're going for it. You gotta go ahead and breathe out as you chew. Breathe out as you chew.
What is it? Look at Mr. Shepard.
All right, give a big round of applause for our volunteers. Thank you so much for being brave enough to try. I don't know what the best. You can keep it or you can take it, either way. We'll shift gears a little bit here.
Great job, guys.
What do I have here with me? Someone said it. It's an orange balloon. And what's a balloon? Go ahead and roll them out.
Gas inside.
Gas inside, amazing. Yes, we have gas inside. And then how about, what else is going on? Solid, right? The actual balloon here is a solid, amazing. I'm glad I have so many volunteers shouting out. Okay, so could people remind me once again what our gas dance looks like?
Oh, nope.
Yes, we got our energized gas molecules, right? So that's inside the balloon. And then our solid looks like what again? Yeah, amazing. We got those molecules staying pretty close together. So our balloon is actually made of like a special kind of solid. It's got something called elasticity. So a lot of solids, when they pull them really hard, they break apart. But materials like what a balloon's made of does have something called elasticity, which means it stretches. So the dance for our balloon, if it was under some force, could stretch and then return to the way it was, right? But it's got that ability to come stretch out. We can blow them up. Nice. All right, so we can keep that in mind. I'm going to go ahead and pour some liquid nitrogen on the top of this balloon. Can I get some hypotheses on what will happen? You can call them out.
It's gonna burst.
It'll pop. Maybe it'll shrink, I heard. All right, it will freeze. All right, I love all of these ideas. Let's go ahead and try it out. So I'm gonna go ahead and pay close attention to what's gonna happen here, and then I'll ask for your observations in a little bit. So I'm gonna go ahead and pour, and there might be a little sound element that you'll wanna pay attention to, so make sure to listen. All right, so I'm gonna go ahead and start pouring on this balloon. Go ahead and watch carefully about what's happening here.
Oh. It melted.
Do you guys hear that? I'm gonna try it one more time so you guys can watch. So here's our balloon. I'm gonna add some liquid nitrogen.
My video's all grainy.
All right. And I'll pull it out so you guys can hear.
Take a bite. I want to take a bite.
It's very cold, so I'm gonna keep holding it with my gloves here. All right. Okay. So what happened? What did we notice? Yeah. What happened to the size? Someone out there, can you call out? It shrunk. Absolutely. Yes, it shrunk. And then what happened when it got warmer? When it was away from the liquid nitrogen? It re-expanded. Amazing. Okay. What about the sound? What did people notice about the sound? It was crunchy. Yeah, it kind of sounded like a chip bag. And then how about now? If I tap it now? Yeah, now it's kind of back to normal, right? All right, amazing. So we can explain this a little bit with our matter dances. Okay, so remember what gas was again? You guys are experts. Yes, you know your gas dance. Okay, amazing. So when that gas was exposed to those cold liquid nitrogen temperatures, it was still a gas, but it got less energetic, and it got a bit smaller. Oh, it shrunk down, a little less energized. But then as it warmed back up, away from that liquid nitrogen, it could be its total regular gassy self taking up the same amount of space. All right, how about the solid? We had that elastic balloon, right? But as it got colder, it too became more rigid. And it kind of gave it that chip bag, crunchy, crispy kind of sound. Then as it warmed back up, whew, it got back to its regular, very nicely elastic self. All right. I did hear some people say that the balloon was going to pop. Was anyone looking forward to that pop? Some people yes, some people no. Okay, so I will advise that people do cover their ears for this one, especially if you don't want to hear a pop, but it is pretty loud, so I might just say everyone should do that. But we're going to try to make a balloon pop by putting some liquid nitrogen inside of it. What's going to happen if we put the liquid nitrogen inside of the balloon?
It would expand.
Yeah, it's going to take up more space, right? Because again, our liquid nitrogen is boiling when it's exposed to room temperatures. So it's going to take up a lot more space and it's going to expand. So this doesn't always work, but I'm gonna go ahead and give it a shot, and I'll let you guys know when it is necessary to cover your ears. So I'm going to put my safety hearing muffs on.
Shivery timbers.
And I'm going to go ahead and fill up this beaker with some liquid nitrogen, and then I'm going to try to do a little flipsy-do and get it into our balloon. All right. So now would be a good time to start covering your ears.
I have light covered. How loud is this going to be? It's going.
It got me.
Alright, so our science was
I screwed up some of the video.
We had that liquid nitrogen undergoing a phase change from liquid to gas, taking up a lot more space. Alright.
I screwed up my
I've
video.
got one more experiment for you guys today. Would anyone like to see me try to turn this plastic water bottle into a rocket? Yes, I mean, what a question, right? How do you think we're going to be able to do that? Yeah, like we see with the balloon, right?
Pressure.
Maybe we'll be able to pour some liquid nitrogen in here, build up enough pressure, like we're building pressure inside that
And it shall
balloon,
go
to create some thrust and send our balloon flying. All right, so I'm going to go ahead and I'm going to pour a little liquid nitrogen into the base of this bottle. We'll flip it over, and then we will see if we can get a little successful takeoff. In a minute, could I ask you guys to count down for me, maybe a 5, 4, 3, 2, 1 on takeoff? Okay, I'll start on at 5 in just a second. All right, we'll do that just one more time. All right, you guys ready? Okay, great.
Somebody touch him. Touch it with your bare hands. It's safe.
All right, that concludes our show today. Thank you for being such a wonderful audience. I love hearing all of your hypotheses and ideas. If anyone has any questions, feel free to come up front and ask me about them. Just remember to not cross this